welcome back to part 2 of our lesson on atoms and elements of the periodic table. Now, just gonna do a little summary of what we spoke about before going into part 2. So, we went way back to biology to remember about the fact that atoms are the basic parts of life. And one thing that I did not point out is that groups of atoms make up elements, and that is why we're also focusing on the elements and describing the arrangement of particles on within them, within the atom. Now, we also discussed the periodic table. We looked at the first 20 elements based on, we numbered them based on their atomic numbers. And we looked at the chemical symbols like we're seeing here. At the end of that part 1, which is the nuclear annotation, we spoke about the fact that the letters, they use letters to represent the chemicals, capital letters, and also if it's two letters, you will have a common one beside it. We also spoke about having a superscript and a subscript, superscript being represented by the mass number, which we know is equal to the atomic number plus the neutrons, number of neutrons. Also, the subscript would be represented by atomic number equal number of protons, right? And if we didn't say it before, also the electron would be equal to the number of protons in a stable atom. So once the atom is stable, we'll also have an equal number of electrons as protons. Now, we also did a really fun exercise, which I'm sure most of you would have figured out by now, but I just wanted to share what I was thinking in regards to the responses. Again, we spoke about the can, that can there, which would be represented by aluminum. That is the element I was thinking about. We have a diagram there, or a picture there of banana. And if we also go back to biology, I don't know if you're noticing, but the trend is that everything is connected. Biology, chemistry, from chemistry back to biology. Yes, so that's all about STEM. But anyways, the banana would contain potassium, which is very important for us, and even traces of magnesium and calcium. So, kudos to you if you figure that out, or if you remember that from your previous lessons, kids. We also have a diagram here of a pool, and we all should know what traces of what element is found in the pool, which would be chlorine. So that's where I was going with that diagram. And last but not least, we see there gas gauge. This is a picture, or part of a picture that we would see at the hospital, because people need oxygen. So oxygen is one element. It could have said another gas, but basically, since it's a gas gauge, then it's all about being a gas, one of the gases. Yes, so kudos to you if you figured that out. You weren't just thinking on the surface, you use critical thinking somewhat. So that's what we are really looking to have our students thinking, how we are looking to have our students thinking, so that learning will take place. Alright, so let's go right into part 2 of the lesson. Now, we spoke about all the particles such as electrons, protons, neutrons, but we are now giving them a name. They are referred to as subatomic particles. if we look closely at this table, we will see where it represents, it has details in regards to the mass units, relative electron charge, and also the atomic location. Now the proton, and the proton has a positive charge, while the neutron is zero, neutral, so to speak. And both of them, they are found in the nucleus, and we did discuss that before. The electron, they are found on the outer shell, or referred to as the orbital, and we're going to talk about that in the following slides. You also have where the electron, it is negatively charged. Yes, so basically the only, on this diagram, this table, if we're to summarize, we are seeing where only the neutron is neutral. So the proton is positive while the electron is negatively charged, right? Now, next slide. There's a few pointers I want to bring across, some basic concepts that when you are being administered, you're being tested or being administered to you, you're taking your test, you're asked to do activities related to like drawing electronic configuration or representing the subatomic particles. These points will help you remember what to do and to do it correctly. Now, the first shell of the electron, the first shell on the atom would hold up to 2 electrons. So that shell would be a pair. And by the way, let me just pause to say that these orbitals or shells that we refer to, we're not gonna, if we look on the microscope or so, we're not gonna see literal circles or rings or orbitals. No, it's just to help you understand the concept a little better, so it's represented like that, right? So the first shell would hold up to 2 electrons, or a pair. The second shell now would hold up to 8 electrons. So when these are being distributed as well, they can be paired on that second shell. For the third shell now, that typically can hold up to 18 electrons. But just stick a pin right there. Remember that we are talking about the first 20 elements of the first 20 elements of the periodic table. So you have to remember that for these elements, we will be seeing mostly a maximum of 8 electrons on the third shell. So for the first 20 elements of the periodic table, you would be seeing a maximum of 8 electrons, or you should see a maximum of 8 electrons on the third shell. However, only potassium and calcium does have a fourth shell, and that would be to accommodate additional electrons that cannot hold on the third shell, which only hold up to 8 electrons, right? So I hope that was really clear to you. Now we're going to actually look at a diagram or a drawing of what we just said to put everything together. Now we have there that green ball, which would represent the nucleus, which we now know that it contains the protons and the neutrons. We also see those white circles that would represent imaginary like shells or orbitals, and we also see the blue or teal dots or balls that would represent the electrons, right? So as discussed before, previous slide, the first shell can hold a maximum of 2 electrons, right? Yes, you have a pair there, so that's the maximum. No more than 2 can hold on that one. So that means any additional electrons would have to be distributed on the second shell. We also learned that the second shell hold a maximum of 8. So now you have 8 on this one. You now have 8. So this shell is quite full. It's booked out. And we now see where they're being represented as pairs here. So that's a full shell. But look at this. There's one more electron that needs to be accounted for, but it cannot hold. Therefore, it has to go on to the third shell right there. So that's the concepts that we just saw in words. Right, so next slide. So this diagram is a representation of the first 20 elements of the periodic table, and we're gonna look at a few of them, and I'd really love if what you can do, you can pause the video and maybe try to walk through yourself the rest after I explain using this diagram, explain a second time using this diagram, since we're actually looking specifically on the elements, the 20 elements, the first 20 elements. Alright, so let me just enlarge this quickly so that we can see. Alright, so we start at the top. We have hydrogen, and I must apologize on the first part 1. When I was looking at the periodic table, I said helium, but that one was actually hydrogen. So we're back at hydrogen now. So we're looking at hydrogen. So hydrogen, even though the maximum electrons that the first shell can hold is actually 2, because hydrogen only has 1 electron, that's the only one that's going to hold on that shell. So that's fine. The second element we see there, lithium. So we know lithium has an atomic number of 3, right? So we know again that the first shell can only hold 2. Therefore, the additional shell would have to be distributed on the second. The additional electron would have to be distributed on the second shell. So that third electron there all by its lonesome self on the second shell. Alright, so we can maybe also look at aluminum, as we've been focusing on that element. So again, first shell can hold a maximum of only 2. Let's enlarge this a little bit more so you can see. Yes, so only 2. And then we said the second shell hold a maximum of 8. So they are paired up, and the first and second shells, they are maxed out. But look at this. Aluminum has an atomic number of 8, 9, 10, 11, 12, 13. So there are 10 accounted for already based on the shells, but there's three more.